Okay, so continuing on for lesson 13, topic C. Store A and B both sell oranges. The table shows the total cost in dollars and the number of pounds of oranges at each store. And so we're going to look at part A. It says, does the table for store A represent a ratio relationship? And we need to explain if it does, why it does. All right, so how can we determine if it is in fact a ratio relationship? They would need to be equivalent ratios, right? So let's look at this. Can we go from 4 to 8? Yes. How do we do that? 2 times, right? So what is 6 times 2? 12. And then how do we go from 4 to 12? Times 3. So 6 times 3 is 18. And then how do we go from 4 to 16? Times 4. And 6 times 4 is 24. So yes, the table does represent a ratio relationship. And how do we know? Because 4 to 6, 8 to 12, 12 to 18, and 16 to 24 are equivalent ratios. And I proved that with the math by multiplying each number by the same number. All right. And then does table B represent a ratio relationship? Explain. And you can go about the same process. If we double 5, we get 10. So if we double 9, we get 18. So we're doing the same thing. We're multiplying by 2, both of those numbers, and we're getting 10 to 18. So we're creating an equivalent ratio. Then we're going from 5 to 15, so times 3. 9 times 3 is 27. 5 times 4 is 20. 9 times 4 is 36. So it would be the same exact answer. So yes, the table does represent a ratio relationship. And the answer is because, and I should probably just put a comma right here instead of a period, because, and then you can label them 5 to 9, 10 to 18, 15 to 27, and 20 to 36 are equivalent ratios. Okay. All right. Now the next question says, do the two tables represent the same relationship? And then explain. All right. So for these types of problems, you have to have a direct comparison. Okay. So for a direct comparison, I'm going to go ahead and I'm going to try to erase all of this. I can get this out of the way. Oh, maybe not. Let's try again. Okay, so for a direct comparison, we are looking to find a number where both of the tables or both of the graphs or the table and the graph or the double number line have the same number in one of the spots. Okay, if they have it in both of the spots, then it would be an equivalent ratio. But in this case, we're looking for at least one number that's the same for both of them. And the number that I'm going to use or that I see that's the same for both of them is 18. And it represents the total cost for both of them. So I'm comparing the same thing, total cost. All right. And so what is my comparison? So my ratio for store A is going to be 12 to 18. And my ratio for store B is going to be 10 to 18. And I want to know, are those two things equal? No, because when it costs $18 at store A, I'm getting 12 pounds of oranges. And when it costs $18 at store B, I'm only able to buy 10 pounds of oranges. So these two things are not equivalent. So we have our direct comparison, 12 to 18 to 10 to 18. They are not the same. So no, they are not, or they do not have the same ratio relationship. So I'm answering the question and then I'm explaining it. So how do I know that those two things are not equivalent? So I want to explain what those things represent. So in store A, you can buy 12 pounds of oranges for $18. And in store B, you can only buy 10 pounds of oranges for $18. So for the same price, $18, in store A, you could buy 12 pounds of oranges. In store B, you can only buy 10 pounds of oranges. So it's not the same. Store A, you get more oranges for the same amount of money than you do in store B. All right? So then the next question says, which store charges more per 1 pound of oranges, and explain. All right. So for this one, I'm going to compare them to 1 pound of oranges. I would like to get the unit rate and find out how much it costs per pound. So what I suggest you do is set up a table. So we're going to need a table for A, and we're going to need a table for B. And this is going to be my pounds of oranges. And this is going to be my cost in dollars. And I want to know 1 pound is how much for both of them, because I can't compare them without a direct comparison. And I want to know how much it costs per pound. So now I'm going to go ahead and I'm going to put in my lowest number that I get in the table. So for store A, my lowest one is I can get 4 pounds of oranges for $6. And for store B, I can get 5 pounds of oranges for $9. And I'm getting this directly from the table. If you go back and look at the table, I'm getting this from right here and right here. Okay, so now how do I go from a 4 to a 1? I have to divide by 4. So I'm going to take 4 divided by 4, and that's how I go from a 4 to a 1. So whatever I do to this ratio, I have to do to this ratio. So this is going to end up being 6 divided by 4. And I'm going to do the same thing for store B. So 5 divided by 5 is going to give me 1. So this is going to be 9 divided by 5. And for right now, we're just going to leave it as a fraction. So now I need to compare 6 over 4 and 9 over 5. And it's talking about money. So I want to rewrite this in terms of dollars. So 6 over 4, you have a bunch of different options. You could do 6 divided by 4. So 6 divided by 4, you're going to end up with 1 2/4. Okay, and when we're talking about money, if you have 2 quarters, that's 50 cents. So we're going to rewrite this as $1.50. And then store B is 9/5. So you can do 9 divided by 5, and you're going to end up with 1 4/5. And the easiest thing for me is to change this to tenths. So you're doing 2 times 4 and 2 times 5, so that we can change that to 1 8/10. Because if we have 8/10, we know that this is $1.08. So that's $1.80. All right. Another way you could do it is you could actually do 4 divided by 5. 5 goes into 4 no times. So then you add the decimal at the top and you move it over. And so then you have 5 goes into 40 8 times, and it's 8/10. So either way, you get the same answer. For me, it's just easier if I change the fraction to tenths because I know this is the tenths place. And so whatever I have out of 10 becomes the number that goes in that place. All right, and so now it's really easy to see. Store A, I get 1 pound of oranges for $1.50, and store B, I get 1 pound of oranges for $1.80. So which store charges more per 1 pound? That would be store B. Oh, sorry. All right. And then number 3, Lisa and Tara run laps at soccer practice. Both girls record the number of minutes they run laps into ratio tables. Who runs faster? Okay, so we have to have a direct comparison. So we need to find something that shows the same amount or the same number. And so I automatically number of minutes 20 for Lisa and number of minutes 20 for Tara is popping out at me. And so what is our direct comparison? 20 to 10 for Lisa and 20 to 10 for Tara. So what does this mean? These two ratios are equivalent to each other because when she runs 20 minutes, she has ran 10 laps. And when Tara runs 20 minutes, she has run 10 laps. So this is kind of like a trick question, I guess, but Lisa and Tara run at the same speed. Neither of them is faster. Okay, so now we have our direct comparison and we have our restate and answer the question, and now we need to explain it. So what does 20 and 10 represent? So they both run 10 laps in 20 minutes. So you're just explaining what that ratio represents for this problem. All right. Let's see. Question number 4. Mr. Sharma's class mixes dye to make tie-dye shirts. They mix yellow dye and red dye to make 2 different mixtures of orange. Which mixture should appear more yellow? So which one should appear more yellow? Use the information in the tables to support your answer. Circle the table rows used to determine your answer. So it wants me to circle instead of highlight. Usually I highlight. Okay, so let's circle. So we are looking for a direct comparison. So you are trying to find somewhere in the table where they are the same. All right, and I notice they both have 35 in the number of parts red dye. So I'm looking at this, and I'm looking at the other one that also has 35. I'm gonna go ahead and highlight the 35. So 35 is the number of parts red. So they have to be the same for both of them in the same column, okay? So like, for example, you can't circle 30 in this column, red dye, and 30 in this column, yellow dye. Because even though 30 is the same number, it's not talking about the same thing. In this one, 30 is red, and in this one, 30 is yellow. So it's not the same, all right? They have to be the same in the same column. All right, so we have that. Okay, and so now we can have a direct comparison, right? So we have 21 to 35, and we have 25 to 35. So are these two things the exact same? No, they're not equivalent, right? So one of them is going to be more yellow. So what does that mean? When they have the same amount of red, they both have 35 red, they have the same amounts of red. Who has more yellow? Mixture B. All right, so mixture B should appear more yellow. All right. And what's another math that we can compare, we can show is 25 is greater than 21. So you're going to have 25, you're going to have 4 more parts yellow in mixture B than you will in mixture A. So that one should appear more yellow. All right. And then number 5, and this is the last one for this lesson. Lacey, Riley, and Adesh each make orange and vanilla ice pops using the same 2 ingredients. The tables show the number of cups of orange juice and the number of cups of vanilla yogurt used by each person. All right, so now we're comparing 3 different people. But that's okay because we are going to follow the same concept. So it says, based on the tables, order the ice pops from the one that should have the strongest flavor to the one that should have the weakest flavor. And then we're going to explain how you use numbers in the table to determine our order. So we're going to go and we're going to look in the table and we're going to find numbers that are the same, and they have to be in the same column. So we have to be talking about the same thing. So the first one that jumps out at me is 12. We have 12 in the yogurt column. So 12 in the yogurt column for all of them. So because we're keeping the yogurt the same for all of them, we want to know which one would have the strongest orange flavor. So since the yogurt is the same, we want the highest number of orange juice because that's going to have the strongest flavor because we have the most orange juice in that pop, that ice pop. All right, so let's see. So how are we going to do this? So we're going to put them in order. So Lacey, let's see. Lacey has 10 to 12. And then Riley has 8 to 12. And Adesh has 9 to 12. And so if we're ordering the numbers, the 12 is staying the same for all of them. If we're going to order these numbers, it would be 10 would be the greatest, the strongest flavor, then 9, then 8. All right, so we need to put them in order. So who is 10 to 12? That's Lacey. So Lacey's ice pop has the strongest flavor, orange flavor. Then who's the 9? 9 to 12 is Adesh. And finally, Riley's ice pop would have the weakest orange flavor. All right, and again, it's because Lacey has 10 cups of orange juice, and then Adesh has 9 cups of orange juice, and then Riley has 8 cups of orange juice. And so we know that 10 is the greatest, then 9, then 8. All right, that's the order from strongest to weakest. All right, and that's all for lesson 13.